Chapter 1. The Anomalous Gravitational Whisper. The faint hum of the interferometer had become as familiar to Dr. Ethan Carter as the rhythm of his own heartbeat. For the past decade, he had been stationed at the Laser Interferometer Gravitational Wave Observatory, LIGO, facility in Hanford, Washington, listening for the cosmic whispers that rippled through space-time. But on this crisp October evening, something was different. The gentle vibrations on the sensor graphs had evolved into an irregular tremor, a disturbance that defied the predictable patterns of known celestial events. Ethan squinted at the monitor, his brow furrowing as he cross-referenced the data with the latest updates from NASA's Jet Propulsion Laboratory. The gravitational wave readings were inconsistent with the expected signals from binary neutron star mergers or black hole collisions within the Milky Way. Instead, they hinted at a single, massive object moving to the galaxy with an unusual trajectory, something that shouldn't exist in the meticulously mapped regions of the solar neighborhood. "Sarah, you need to see this." Ethan called out to his colleague, Dr. Sarah Moore, a planetary physicist who had been analyzing data from the Parker Solar Probe. Her office was just down the hall, and he could hear the clatter of her keyboard cease as she responded. Sarah entered the control room, her curly auburn hair tied back in a messy ponytail, her glasses sliding down the bridge of her nose as she leaned over the desk. "What am I looking at, Ethan? Another glitch in the system? We just had the detectors calibrated last week." "Not a glitch," Ethan said, his voice steady but laced with a hint of urgency. "These are gravitational wave signatures, but they're not from a binary system. It's a single mass, something incredibly dense, and it's moving closer to the solar system than anything we've ever detected before." Sarah's eyes widened as she processed the data. "A rogue black hole?" she whispered, the words hanging in the air like a forbidden thought. Rogue black holes, stellar remnants that had been ejected from their birth galaxies or formed in the early universe, were theoretical constructs. Until now. The idea that one could be approaching the solar system was a kind of scenario reserved for science fiction, not the cold, hard numbers on their screens. Using the LIGO data, Ethan had already begun to model the object's trajectory. The results were chilling. The black hole, estimated to have a mass of around 50 solar masses, was moving at a speed of 2,000 kilometers per second, on a path that would bring it within 500 astronomical units, AU, of the Sun in just 18 months. For context, $1 is the distance from the Sun to Earth, about 150 million kilometers. $500 was within the Oort Cloud, the hypothetical sphere of comets and icy bodies that marked the outer edge of the solar system. As news of the discovery spread through the scientific community, astronomers around the world turned their telescopes to the region of space where the rogue black hole was predicted to be. The Hubble Space Telescope, despite its limited resolution for such distant objects, captured a faint distortion in the light from background stars, evidence of the gravitational lensing effect caused by the black hole's immense mass. It was a wispy, ethereal proof, a bending of reality itself around the invisible behemoth. On Earth, the first tangible effects were subtle but undeniable. The orbits of the outer planets, Neptune and Uranus, began to show slight perturbations, their gravitational dance with the Sun disrupted by the distant mass. Astronomers at the United States Naval Observatory in Washington, D.C., noticed that the timing of Uranus ring occultations was off by milliseconds, a discrepancy that could only be explained by an external gravitational influence. Closer to home, the moon's orbit around Earth began to change. The black hole's gravity, though weak at this distance, was enough to alter the delicate balance between the Earth-Moon system. Tides became more erratic, with high tides rising an average of 10 centimeters higher than normal along the world's coastlines. In places like the Bay of Fundy, known for its extreme tides, the difference was even more pronounced, reaching an additional 30 centimeters. Fishermen and coastal residents began to notice the changes, though most attributed it to natural climate variability. For Ethan and Sarah, the reality of the situation was sinking in. They found themselves in a conference room at NASA headquarters in Houston, Texas, presenting their findings to a panel of top scientists and government officials. The room was tense, the air heavy with the weight of their words. "Let me make sure I understand," said Admiral Rachel Torres, the head of the U.S. Space Command. "You're telling us that a black hole, a literal black hole, is coming towards our solar system, and in less than 2 years, it will be close enough to start causing significant gravitational disturbances?" "Yes, Admiral," Sarah replied. "At 500 Australian dollars, its gravitational pull on the Sun will be about 1% of the Sun's gravitational pull on Earth. While that might not sound like much, over time, it will disrupt the orbits of the outer planets, and as it gets closer, the effects on the inner solar system will become more pronounced. At 100 Australian dollars, which it will reach in about 16 months, the gravitational influence on the Sun will increase tenfold, causing more significant perturbations in the planetary orbits." Ethan chimed in, "And let's not forget about the Oort Cloud. The black hole's passage through the outer reaches of the solar system will send a shower of comets and icy bodies towards the inner solar system. We're talking about thousands, maybe millions of comets being disturbed from their stable orbits. Each one of these could potentially pose a threat to Earth if their trajectories intersect with ours." The room fell silent, the implications of their words sinking in. The survival probability progress bar, which had started at 70% when the first gravitational waves were detected, now hovered at 65%. The realization that a cosmic behemoth was bearing down on the solar system, invisible yet inevitable, was a harsh reminder of humanity's fragility in the face of the universe's raw power. As the meeting adjourned, Ethan and Sarah stepped out into the Houston night, the glow of the city lights dimming the stars above. "What do we do now?" Sarah asked, her voice quieter than usual. Ethan sighed, staring up at the sky as if he could see the rogue black hole lurking in the darkness. "We keep watching, we keep calculating, and we prepare for the worst. The world needs to know what's coming, but we also need to give them hope that we can survive this." Little did they know, the next phase of the crisis was already beginning. The subtle gravitational perturbations were about to escalate, and the first major celestial event, a close encounter between the black hole and a distant Oort Cloud comet, would set off a chain of events that would change the solar system forever. The cosmic storm was gathering, and Earth was in its path. Chapter 2. The Comet Storm Begins. 6 months had passed since the rogue black hole's first gravitational whisper, and the solar system was no longer a stranger to its presence. Now at 300 astronomical units from the Sun, its mass, 50 times that of Sol, was a gravitational sledgehammer, reshaping the outer reaches of the solar neighborhood. The Oort Cloud, a vast reservoir of icy relics from the solar system's birth, trembled under the disturbance. Thousands of comets, once dormant in their distant orbits, were now hurtling toward the inner solar system, their trajectories warped by the black hole's unseen pull. Ethan sat in the control room of the European Southern Observatory's Very Large Telescope, VLT, in Chile, his eyes glued to a mosaic of screens displaying real-time images from the Solar and Heliospheric Observatory, SOHO. The coronagraph instruments had captured the first visible signs of the comet storm, faint streaks of gas and dust glowing against the solar backdrop, each a tiny emissary from the dying Oort Cloud. "We're tracking over 4,000 new cometary trajectories in the past 48 hours, he said into his headset, communicating with Sarah back at NASA's Jet Propulsion Laboratory. "And that's just what we can see. The actual number could be an order of magnitude higher." Sarah's voice crackled through the line, tinged with fatigue. "The JPL team just finished the orbital simulations. At this rate, Earth's gravitational sphere of influence will intersect with at least 120 cometary paths over the next year. Most are small, less than 100 meters in diameter, but 3 of them. She paused, pulling up the latest data. 3 have orbital parameters that bring them within 5 cent of Earth at perihelion. That's close enough for a gravitational slingshot to alter their course. The survival probability progress bar, which had clung to 65% through the initial perturbations, now dipped to 60%. The cold, hard numbers reflected a harsh truth. The cosmic dice were rolling, and humanity was at the mercy of orbital mechanics. On Earth, the moon's orbit had elongated significantly, its perigee, closest approach to Earth, decreasing by 15,000 kilometers. The result was a tidal nightmare. In the Bay of Bengal, high tides now surge 2.5 meters above normal levels, flooding low-lying islands in Bangladesh and the Ganges Delta. The Indian National Center for Coastal Research reported saltwater intrusion into freshwater aquifers, threatening drinking water supplies for millions. Along the Pacific coast of North America, the California Coastal Commission issued emergency evacuation orders for communities within 500 meters of the shoreline as king tides combined with storm surges to breach seawalls. In space, the Global Positioning System, GPS, began to falter. The black hole's gravitational gradient caused minute but cumulative errors in the satellite's atomic clocks, disrupting navigation systems worldwide. Airlines were forced to revert to manual flight plans over the Pacific, while maritime vessels relied on celestial navigation for the first time in decades. The European Galileo satellite constellation fared no better. Engineers at the European Space Operations Center in Darmstadt scrambled to upload real-time correction algorithms, but the sheer unpredictability of the gravitational field made it a losing battle. Ethan boarded a NASA Gulfstream jet bound for the LIGO facility in Livingston, Louisiana, carrying a portable gravitational wave detector. The plan was to cross-correlate data from both LIGO sites to get a more precise fix on the black hole's mass and velocity. As the plane banked over the Gulf of Mexico, he gazed out the window at the churning waves below, waves that had grown taller and more erratic, their patterns no longer dictated solely by the moon and sun, but by an invisible interloper 300 billion kilometers away. At JPL, Sarah stood in front of a holographic model of the solar system, watching as cometary trajectories lit up like a celestial fireworks display. The most concerning was Comet 2025 Q1, nicknamed Nightingale by the team after the first songbird to fall silent in the early days of the crisis. Measuring 2.3 kilometers in diameter, Nightingale was on a hyperbolic orbit that would bring it within 1 cent of Earth in 11 months. "It's not the impact we need to fear," she told a room of international delegates via video conference, "but the gravitational handshake. Even a near miss could tweak Earth's orbit enough to disrupt climate patterns for decades." The delegates, representing the United Nations Office for Outer Space Affairs, listened in stunned silence. The International Asteroid Warning Network, IAWN, had been activated, but their protocols were designed for known asteroids, not a swarm of comets birthed from the death of the Oort Cloud. The only feasible defense, nuclear deflection, was hampered by the sheer number of threats and the uncertainty of their trajectories. Back in Chile, the VLT's adaptive optics system captured a breathtaking yet terrifying sight, a cluster of comets, their tails merging into a glowing ribbon of ionized gas, streaked across the southern sky. To the naked eye, they appeared as a celestial parade, a cosmic spectacle that drew crowds to hilltops and beaches. But astronomers knew the truth. Each comet was a fragment of the solar system's primordial past, now weaponized by the black hole's gravity. In the streets of Santiago, panic began to simmer. Social media was flooded with videos of massive tides swallowing coastal towns, of GPS-guided cars veering off roads, of comets blazing across the night like omens of doom. The survival probability progress bar, now a tangible symbol of hope or despair, dominated news cycles. Scientists appeared on every major network, explaining the physics behind the crisis, but their words were often drowned out by the rising tide of fear. Ethan and Sarah reunited at LIGO Livingston, their faces gaunt from sleepless nights. The latest gravitational wave data was worse than expected. The black hole had accelerated slightly, its velocity now 2,100 kilometers per second, likely due to gravitational interactions with the Oort Cloud's collective mass. "It's feeding on the debris," Ethan muttered, scrolling through the waveform graphs. Every comet disrupts adds a tiny kick to its trajectory. "We're dealing with a dynamic system here, not a static mass." Sarah nodded, pulling up a simulation of the inner solar system. Mercury's orbit, already the most elliptical, was showing signs of instability, its perihelion precessing at an anomalous rate. Venus and Earth weren't far behind. Their orbital periods were shifting by milliseconds, a change that would compound over time. "The sun itself is reacting," she said, pointing to helioseismic data from the Solar Dynamics Observatory. "The black hole's gravity is causing subtle oscillations in the sun's photosphere, like a drumhead being tapped by a giant hand." As night fell over Louisiana, Ethan stepped outside the LIGO facility, the hum of the interferometer pipes a constant drone in the background. The sky was clear, and for a moment, he forgot the crisis, captivated by the sheer number of stars visible in the rural darkness. Then he saw it, a faint, fuzzy patch where no star should be, the gravitational lens effect of the rogue black hole warping the light of a distant galaxy. It was a silent predator, invisible yet omnipotent, reminding him of how small, how fragile, humanity's corner of the universe truly was. Back inside, Sarah received an urgent message from the Hubble team. The black hole's event horizon, though still too small to resolve, was causing a detectable distortion in the solar wind. The Parker Solar Probe, now within 8 solar radii of the Sun, had measured a 15% increase in solar wind velocity, a turbulent outflow driven by the Sun's gravitational struggle with its cosmic intruder. The chapter closed with a somber realization. The rogue black hole was not just a distant threat. It was a gravitational conductor, orchestrating a symphony of destruction across the solar system. Comets rained from the sky, tides became tidal waves, and the very fabric of space-time hummed with the black hole's approach. The survival probability progress bar, now at 60%, was a stark reminder that humanity's time was running out, and the next phase of the crisis would test the limits of both science and survival. Chapter 3. The Mars Incident. 9 months after the initial gravitational wave detection, the rogue black hole loomed at 200 astronomical units from the Sun, its mass now a gravitational monolith reshaping the inner solar system. The Oort Cloud comet storm had evolved into a cosmic hailstorm, with over 10,000 confirmed objects hurtling toward the Sun. But the first catastrophic impact wouldn't target Earth. It would strike Mars, the red planet caught in the crossfire of gravitational chaos. Ethan stared at the high-resolution images from the Mars Reconnaissance Orbiter MRO, his knuckles white as he gripped the edge of the control console at NASA's Goddard Space Flight Center. Comet 2025X7, a 5-kilometer-wide ice and rock behemoth, had impacted Mars' southern hemisphere at 60,000 kilometers per hour. The resulting explosion, captured in real time by the InSight lander seismometers, registered a 7.8 magnitude quake, the most powerful ever recorded on the planet. The impact threw up a debris cloud estimated at 500 billion tons, he said hoarsely, addressing the global emergency broadcast team. Mars' atmosphere just took a direct hit. Sarah, monitoring data from the Hubble Space Telescope's new Wide-Field Camera 3, saw the aftermath unfold like a slow-motion nightmare. The impact had vaporized millions of tons of Martian regolith, releasing a plume of dust and water vapor that temporarily obscured the planet's surface. More critically, the The rogue black hole's gravity had already altered Mars' orbital eccentricity by 0.03%, pulling it 1.2 million kilometers closer to the Sun at perihelion. "This isn't just a strike," she told the United Nations Emergency Assembly. "It's a gravitational domino. Mars' destabilized orbit will resonate with Earth's in 180 days. We're looking at a gravitational slingshot effect that could shave 0.001% off Earth's orbital period." On Earth, the Moon had retreated to a mean distance of 425,000 kilometers. Its gravitational pull now a flickering shadow compared to the black hole's growing influence. The tides, once ruled by lunar cycles, were now chaotic symphonies of water. In the Philippines, the Pacific Tsunami Warning Center detected a 7-meter-high black hole tide crashing into Luzon, submerging coastal villages and triggering a nuclear emergency at the Bataan nuclear power plant. Engineers scrambled to prevent a Fukushima-style meltdown using seawater, now contaminated with radioactive debris, to cool the reactors. The survival probability progress bar, a now ubiquitous graphic on every screen, dipped to 55%. Humanity's confidence ebbed with each gravitational tremor. In space, the International Space Station, ISS, became a frontline observation post. Astronauts aboard the station witnessed the Mars impact debris cloud firsthand. Tiny flecks of red, dust pinging off the station's hull like cosmic shrapnel. One particularly large fragment, 3 meters in diameter, narrowly missed the station, burning up in Earth's atmosphere as a brilliant fireball over the Gobi Desert. "It's a preview of what's to come," Radio Commander Elena Marquez to Mission Control. "Every rock, every speck of dust from Mars is now a potential threat in this gravitational minefield." Back on Earth, the European Space Agency's ESA near-Mir telescope detected a swarm of 100-meter-class comets trailing Comet Nightingale, their orbits locked in a gravitational dance with the rogue black hole. The JPL team calculated a 12% chance that one of these Nightingale's cubs would intersect Earth's orbit within 6 months. The only feasible defense, the Nuclear Astrophysics Gravity Lensing Experiment, NAG, was rushed into development. A joint U.S.-Russia mission planned to detonate a 10-megaton nuclear device near the closest comet, using the blast momentum to nudge it off course. Ethan and Sarah stood in the control bunker of Vandenberg Space Force Base, watching the Delta IV heavy rocket streak into the night, carrying the NAG payload. "First live test of nuclear deflection on a comet," Sarah murmured, her voice tight with tension. "If this works, we might buy Earth a few more months. If it doesn't..." The mission appeared successful at first. Telemetry showed the warhead detonating 500 meters from the comet's nucleus, creating a visible debris cloud. But the rogue black hole's gravity had the final say. The comet, instead of veering away, began to fragment, its nucleus splitting into 3 smaller pieces, each now on a more unpredictable trajectory. Gravitational gradient tore it apart. Ethan said, slamming a fist into the console. "We just turned one thread into 3. On Mars, the impact had triggered a global dust storm, its intensity surpassing the 2018 event that killed the Opportunity rover. The Curiosity rover, still operational, sent back eerie images of a blood-red sky, its solar panels rapidly accumulating dust. Mission controllers in Pasadena estimated it had only 72 hours of power left before silence. "Goodbye, old friend," muttered engineer Ming Li, tears streaming down her face as she sent the final shutdown command. Back on Earth, the gravitational tug-of-war between the Sun and the black hole caused Earth's axial tilt to fluctuate by 0.05 degrees. The result was a chaotic shift in seasons. North America experienced a blizzard in July, while Australia sweltered under 50 degrees Celsius heat waves. The World Meteorological Organization reported that the jet stream had fractured into a series of gravitational eddies, trapping weather systems in place for weeks. Crop failures became widespread. The breadbasket of Ukraine saw a 40% reduction in wheat yields, triggering food riots in Kiev and Istanbul. In the South Atlantic, the cumulative tidal stress caused a 7.5 magnitude earthquake along the Mid-Atlantic Ridge, displacing a cubic kilometer of seafloor. The resulting tsunami, modeled by the Woods Hole Oceanographic Institution, raced toward Brazil and West Africa at 800 kilometers per hour. In Recife, Brazil, residents watched in horror as a 15-meter-high wave appeared on the horizon, its crest glowing orange in the setting sun. The city's newly built seawall, designed to withstand a 10-meter surge, crumpled like paper, flooding downtown areas and killing over 12,000 people. Ethan and Sarah, now part of the Global Crisis Consortium, met in Geneva to coordinate international response efforts. The mood in the conference hall was bleak, but there was still one card left to play: the Lunar Gravitational Anchor, LGA. A proposal to detonate a series of nuclear charges on the moon's far side, using the resulting explosions to stabilize Earth's orbit by reinforcing the Earth-Moon gravitational bond. It's a Hail Mary, admitted Chinese physicist Dr. Wei Chun, projecting a simulation of the plan. But with Mars destabilized and the black hole approaching, we have no other options. As the meeting adjourned, Sarah stepped onto the balcony, gazing at the moon, now a distorted disk in the sky, its orbit stretched into an ellipse by the black hole's gravity. "Do you think we can win this?" she asked Ethan, her voice barely above a whisper. Ethan didn't answer immediately. He thought of the Mars rovers gone silent, the tsunami victims in Recife, the fractured jet stream choking the planet's weather. "Winning isn't the question anymore," he said finally. "It's about how much time we can buy and what we do with it." The chapter ended with the first LGA test explosion, lighting up the moon's surface, a tiny, defiant spark against the overwhelming darkness of the rogue black hole's approach. The survival probability progress bar, now a stubborn 55%, clung to the edge, a testament to humanity's resilience even as the cosmic storm intensified. The next phase would bring the black hole within 100 astronomical units, a distance where its gravity would begin to tug on the sun itself, threatening to unravel the very heart of the solar system. Chapter 4. The Solar Tremors. 12 months after the gravitational wave first disturbed LIGO sensors, the rogue black hole breached the 100 astronomical unit threshold, close enough for its 50 solar masses to grasp the sun like a cosmic fist. The sun, that eternal nuclear furnace, began to tremble. Helioseismic measurements from the Solar Dynamics Observatory revealed unprecedented oscillations in its convective zone, as if the star itself were gasping under the stranger's gravity. "It's creating tidal bulges on the sun's surface," Ethan explained to a global audience via live stream, his voice strained from 72 hours without sleep. Each bulge is the size of Jupiter, rising and falling every 90 minutes. The first solar response was a series of colossal coronal mass ejections, CMEs, each more powerful than the 1859 Carrington event. The first CME, launched without warning, slammed into Earth's magnetosphere at 2,500 kilometers per second. Satellite imagery from NOAA's GOES 18 showed the aurora borealis stretching as far south as Mexico City, its greens and reds blazing with an intensity that turned night into eerie day. But beneath the beauty lay destruction. Power grids across North America overloaded as induced currents surged through transformers. In Texas, the Electric Reliability Council of Texas, ERCOT, reported 300 gigawatts of power loss in under 60 seconds. The entire state plunged into darkness, followed by the eastern seaboard an hour later. Sarah, stationed at the Goddard Space Weather Prediction Center, watched the geomagnetic storm unfold on her monitors. "KP index just hit 9.5, she shouted into the emergency line, referring to the scale of magnetic disturbances. Every unshielded transformer within 40 degrees latitude is frying. This is a continent-wide blackout. The survival probability progress bar, which had clung to 55% through Mars calamity, now dropped to 50%. Humanity's technological lifeline was fraying. On the ground, the consequences were immediate and brutal. Air traffic grounded, with 5,000 flights stranded midair, pilots relying on dead reckoning as GPS and radio communications failed. In New York City, elevators stalled, subways became tombs of darkness, and hospital backup generators sputtered to life, only to fail hours later as fuel supplies dwindled. The Hudson River, its tides now a chaotic mix of lunar and black hole gravity, surged over the seawall, flooding lower Manhattan up to Canal Street. The solar onslaught continued. A second CME, even more massive, erupted from the sun's western limb, aimed directly at Earth. This time, engineers had 12 hours of warning, thanks to the solar and heliospheric observatory's advanced imaging. The last-ditch effort to protect the remaining global grid involved triggering controlled outages across Europe and Asia, a strategy tested in 2013 during a near-miss CME. We're sacrificing today's power to save tomorrow's, explained Dr. Liang Wei of the Chinese Academy of Sciences, as grid operators across Shanghai initiated shutdown protocols. In space, the International Space Station's crew took emergency shelter in the Russian Zvezda module, shielding themselves from the radiation storm. Cosmic rays, amplified by the black hole's gravitational lensing, pummeled the station's hull, creating a constant hail of subatomic particles. "It sounds like rain on a tin roof," reported astronaut Jack Harper, his voice trembling. "But this rain could fry our brains if we're exposed too long." Back on Earth, the sun's perturbed gravity began to warp Earth's orbit in measurable ways. The Lunar Laser Ranging Experiment detected a 2-centimeter shift in Earth's perihelion, a precursor to more drastic orbital changes. Climate models run by the Max Planck Institute predicted a 1.5 degrees Celsius temperature swing over the northern hemisphere, scorching summers in Canada, polar winters in Spain. In Paris, the Eiffel Tower was engulfed in a freak snowstorm in August, while Mumbai recorded 52 degrees Celsius heat with 90% humidity, a lethal combination that killed over 3,000 in 48 hours. Ethan and Sarah reunited at the newly established Global Coordination Hub in Reykjavik, Iceland, one of the few regions still partially powered, thanks to its geothermal energy grids. "The black hole's gravity is resonating with the sun's oscillations," Ethan said, projecting a hologram of the solar system. "It's like shaking a bowl of marbles. The inner planets are losing their rhythm." He pointed to Mercury, now on an erratic path that brought it 10 million kilometers closer to the sun at perihelion, its surface melting into a volcanic slurry. The Lunar Gravitational Anchor Project, once a hopeful gambit, had failed spectacularly. The first nuclear test on the moon's far side created a 500-meter crater, but did nothing to stabilize Earth's orbit. Instead, the explosion disrupted the delicate balance of the Earth-Moon system, accelerating the moon's recession by an extra 2 centimeters per year. "We overestimated the leverage," Sarah admitted to the assembled scientists. "The black hole's mass is too dominant. It's like trying to fight a tsunami with a bucket." In the southern hemisphere, the effects were equally surreal. The Chilean Andes, normally a barrier to weather systems, saw tropical storms collide with polar air, creating gravitational hurricanes with 300-kilometer-per-hour winds. The Atacama Desert, driest place on Earth, was submerged under meters of rain, triggering mudslides at buried observatories like the Very Large Telescope, ironic tombstones to the eyes that first saw the enemy. Society began to fracture. In regions without power or governance, makeshift communes formed, relying on pre-industrial methods for survival. Blockchain-based barter networks emerged in places like Nigeria and Argentina, using decentralized ledgers to track scarce resources, an echo of the civilization resilience plans drawn up by think tanks in the crisis' early days. But in megacities like Tokyo and Delhi, chaos reigned. Looting, fuel wars, and mass migration strained what remained of law enforcement. The scientific community's last hope rested on the solar gravity shield, an array of 100,000 solar sails positioned between the Sun and Earth, designed to counteract the black hole's gravitational pull by reflecting solar radiation. The project, a joint effort by SpaceX, Blue Origin, and the European Space Agency, was 40% deployed when the second CME hit, destroying 30% of the sails in a cascade of plasma-induced explosions. "We're back to square one," muttered Elon Musk in a rare public address, his usually confident tone hollow. As the chapter closed, Ethan stood on a Reykjavik cliff, gazing at the hyperactive aurora overhead. The lights danced not just with solar particles, but with the invisible gravity waves from the black hole, a cosmic light show celebrating humanity's impending doom. Sarah joined him, silent, watching as a fishing boat was carried inland by a freak high tide, its hull scraping against the rocky shore. "Remember when we thought rogue black holes were just theory?" Ethan said, not looking away from the spectacle. Sarah nodded. "Now they're the theory that's killing us." The survival probability progress bar, now a stark 50%, flickered on screens around the world. Halfway to oblivion, halfway to what? The question hung in the frigid air, as unanswered as the black hole's origin. In 6 months, the interloper would reach 50 astronomical units, close enough for its gravity to shear the Oort Cloud in half, and for the Sun itself to begin a slow, inevitable dance toward the abyss. The solar tremors were just the overture. The real symphony of destruction was about to begin. Chapter 5. The Orbit Wars. 15 months after the gravitational wave detection, the rogue black hole hung at 50 astronomical units from the Sun, close enough for its gravity to turn the solar system into a gravitational maelstrom. The Sun, now visibly distorted in coronagraph images, bulged toward the interloper, its photosphere rippling like molten metal in a magnet's grip. Mercury, the innermost planet, was the first casualty. Its already elliptical orbit had become unstable, its perihelion fluctuating wildly as the black hole's gravity wrestled with the Sun's. On December 12, 2026, radar telescopes lost contact with a messenger probe as Mercury was briefly pulled 20 million kilometers closer to the Sun, its surface melting into a glowing ocean of liquid rock. Ethan stared at the orbital simulations on JPL's mainframe, his eyes bloodshot from staring at numbers that defied hope. "Mercury's gone," he said flatly to Sarah, who was analyzing data from the Gravity Recovery and Climate Experiment GRACE satellite. "Next is Venus. Its orbit's eccentricity has spiked to 0.15. In 3 months, it'll pass within 30 million kilometers of Earth, close enough for a gravitational slingshot that could shred both planets' orbits." Sarah's fingers flew over the keyboard, pulling up thermospheric data. Earth's upper atmosphere was already leaking into space, stripped away by the combined gravitational pull of the black hole and the moon, now a distant speck at 450,000 kilometers. "The thermosphere's losing 10% of its mass weekly," she replied. "At this rate, our magnetic field won't be enough to protect us from solar radiation, let alone the black hole's tidal forces." The survival probability progress bar, a digital omen in every crisis bunker, dipped to 45%. The message was clear. Humanity's window for survival was closing faster than predicted. On the surface, the Earth itself rebelled. The west coast of the United States buckled under a magnitude 9.2 earthquake, the largest ever recorded in the Cascadia subduction zone. Satellite imagery showed the coastline sinking by 2 meters, triggering a 50-meter tsunami that swallowed cities from Vancouver to San Francisco. The USGS reported over 300 aftershocks above magnitude 7.0, each one a hammer blow to the already fractured crust. In Yellowstone National Park, The caldera's ground elevation rose by 15 centimeters in 24 hours, its magma chamber churning under the increased gravitational stress, a premonition of the supervolcano's awakening. The Venus flyby added fuel to the fire. As the sister planet approached, its gravitational pull created a tidal seesaw with Earth, causing the planet's rotation to slow by 0.0003 seconds per day. The result was a 6-minute long day by the end of the month, disrupting biological clocks and global logistics. In Mumbai, a city built for 24-hour cycles, workers collapsed from exhaustion as shift patterns became unmanageable. In London, the stock exchange shut down indefinitely, unable to synchronize trading systems with the erratic timekeeping. The international community's last unified effort, the Solar System Defense Accord, collapsed as nations began prioritizing their own survival. Russia redirected its remaining Soyuz rockets to build a lunar ark on the moon's south pole, while China activated its underground cities in the Lus Plateau, designed to shelter 500 million, but accessible only to party elites. The United States, divided by civil unrest, focused on its Stellar Ark project, converting nuclear submarines into mobile habitats capable of surviving oceanic chaos, though with capacity for less than 1% of the population. Ethan and Sarah found themselves in the ruins of the LIGO Hanford facility, now partially flooded by the rising Columbia River. The interferometers, once humanity's ears to the cosmos, lay shattered, their mirrors cracked by seismic waves. "We should have seen this coming," Ethan said, kicking a bent piece of steel, a 50 solar mass black hole at $50. Its tidal force on the sun is equivalent to 10,000 times the sun-Earth gravity. "We were never going to win." Sarah disagreed, though her voice lacked conviction. "We still have the gravitational lens array, those 200 telescopes we position behind the moon. If we can get a precise mass measurement, maybe we can predict the final trajectory." But even that hope was fading. The black hole's event horizon, now causing visible gravitational lensing of nearby stars, had become a cosmic mirage, distorting the night sky into a kaleidoscope of false stars. Astronomers couldn't distinguish reality from illusion, making precise orbit calculations impossible. On the ground, survival became a daily battle. In the Sahara, a freak cold front dropped temperatures to minus 20 degrees Celsius, freezing nomadic tribes in their tracks. In the Amazon, the gravitational stress triggered a 2,000-kilometer-long rift in the Earth's crust, spewing lava that incinerated entire ecosystems. The World Health Organization reported a 70% collapse in global food production. What remained was controlled by warlords and tech oligarchs, traded in blood and Bitcoin. The final straw came when the black hole's gravity caused the sun to emit a gravity wave flare, a distortion in space-time that disrupted all remaining electronic systems. In an instant, even the geothermal grids in Iceland failed, plunging the last powered regions into darkness. Ethan and Sarah huddled in a makeshift shelter in Reykjavik, listened to the radio, now nothing but static, and watched as the northern lights died, their energy drained by the black hole's dominance. "Remember the first time we saw gravitational waves?" Sarah asked, her voice barely audible over the howling wind. It was a celebration of human ingenuity. Now we're just another failed experiment in the universe," Ethan finished. He stared at his phone, the last charged device, where the survival probability progress bar had frozen at 45%, a fitting epitaph for a species that dared to listen to the cosmos but couldn't outrun its truths. In the final moment of clarity, they received a last transmission from the Hubble Space Telescope. The rogue black hole, now a gravitational colossus, had begun to pull the sun itself into a slow, inevitable spiral. Within a year, the solar system would be a chaotic mess of shattered planets, boiling oceans, and a sun stretched into a stellar teardrop. Humanity's legacy would be written not in stars, but in the echo of a gravitational wave that once hinted at doom. The chapter closed with Ethan and Sarah stepping outside, greeted by a sky where familiar constellations were warped beyond recognition. The Milky Way torn asunder by the black hole's gravity. It was a final, humbling view, a reminder that in the face of cosmic forces, even the most brilliant minds were just spectators to their own extinction. The survival probability progress bar, now a meaningless pixel, blinked once and went dark, as did the hopeless species that had dared to dream beyond its fragile brood. Chapter 6. The Stellar Deformation. 18 months after the first gravitational wave rippled through LIGO's detectors, the rogue black hole lurked at 25 astronomical units, a distance where its 50 solar masses began to knead the sun like cosmic dough. Helioseismic arrays across 3 continents registered a new mode of oscillation, a low-frequency tremor at 0.003 hertz, indicating the star's core was buckling under tidal forces 20,000 times stronger than Jupiter's pull on the inner planets. "The convective zone is fracturing," Ethan murmured, scrolling through STO imagery that showed the sun's surface rippling in 50,000-kilometer waves. "It's not just heating up, it's being stretched apart." The first superflare erupted on the star's eastern limb, a plasmoid the size of Neptune tearing free from the photosphere. Magnetic field vectors, twisted into hyperbolic spirals by the black hole's gravity well, unleashed a 10 superscript 2 joule electromagnetic pulse, 1,000 times the energy of the 1859 Carrington event. Satellites in geostationary orbit became instant scrap metal, their solar panels vaporized. The global positioning system, now a constellation of dead husks, winked out in a 90-second cascade. On the International Space Station, Commander Elena Marquez had just 12 seconds to scream brace for impact before the pulse fried life support systems, turning the station into a coffin hurtling at 28,000 kilometers per hour. On Earth, the ozone layer, already thinned to 150 Dobson units over the northern hemisphere, shattered like glass. UVC radiation, normally blocked by stratospheric ozone, poured onto the surface with a flux of 2.3 watts per square meter. In Nairobi, a mother clutching her infant stepped outside to investigate the eerie green sky. Within 90 seconds, their skin erupted in blistering lesions, DNA strands unzipping under the radiation onslaught. Effective exposure time at equatorial latitudes, 12 minutes, Sarah reported from JPL subterranean bunker, her voice steady only through years of trauma training. Any longer, and cellular membranes liquefy. The survival probability progress bar, projected onto every emergency bunker's wall, dipped to 40%, a number that hung in the air like a death sentence. But the planet's fury was just beginning. In the North Pacific, the Cascadian subduction zone, strained by months of gravitational tug-of-war, snapped like a rusted chain. A magnitude 9.6 earthquake, the largest in modern history, ripped along 1,200 kilometers of fault line, displacing the seafloor by 5 meters. The resulting mega tsunami, a 100-meter wall of water laced with radioactive coolant from Fukushima Daiichi's ruptured reactors, swallowed Vancouver Island in 17 minutes. Satellite imagery showed Victoria submerged under 30 meters of toxic sludge, its skyline crumbling like a child's blocks. Thousands of kilometers east, Yellowstone's caldera, pressured by the black hole's gravitational gradient, began to cough ash into the stratosphere. Ground deformation sensors recorded a 2-meter uplift per hour as 500 cubic kilometers of magma rose toward the surface. "This is an eruption," said Dr. Wei Chun, monitoring seismic data from a bunker in Denver. "It's the planet itself vomiting under the strain. The first pyroclastic flow, traveling at 800 kilometers per hour, incinerated mammoth hot springs in seconds. It's 500 degrees Celsius, ash turning the Rockies into a glowing graveyard." Ethan and Sarah, holed up in a reinforced command center beneath Iceland's Hengil volcano, oversaw the final stages of the Stellar Arc project. 12 SpaceX starships, their hulls reinforced with boron carbide shielding, weighted in a network of lava tubes, humanity's last hope to escape the solar system's death spiral. But the black hole's space-time curvature, now measuring 0.002 radians per AU, created navigational hell. Every star chart was a mosaic of lens images, every sensor feed contaminated by gravitational lensing. It's like trying to sail a ship through a storm of mirrors, Ethan told the 12,000 selected survivors, his voice echoing in the cavernous hangar. Our only landmark is the L2 Lagrange point. Beyond that, we're blind. Sarah, meanwhile, focused on a quieter, more eternal project, the Lunar Library 2.0, using robotic rovers from the Artemis program. She'd overseen the burial of 50,000 terabytes of human knowledge, everything from the Gutenberg Bible to the Human Genome Project, into the regolith of Tycho crater. Even if we don't make it, she said, pressing a diamond-encased data chip into Ethan's hand, this will outlast the solar system, a message that we tried. Their moment of quiet resolve shattered as the volcano rumbled. Seismic monitors showed magma rising at 100 meters per second, just 5 kilometers below the surface. The first Starship Endeavour began its pre-launch sequence, its 33 Raptor engines humming like a metallic choir. Through a porthole overlooking Reykjavik, Ethan and Sarah witnessed a scene from a cosmic nightmare. The sun, now an oblong inferno stretched 200,000 kilometers toward the black hole, cast a blood-red glow over a city torn apart by fissures. The moon, visible as a distorted ellipse, hung low in the sky, its surface pockmarked by new craters from Oort Cloud debris raining down. Remember our first date? Sarah shouted over the Engine's roar, a rare smile on her ash-streaked face. At the Griffith Observatory, arguing about dark matter over stale popcorn? Ethan laughed, a sound both joyful and desperate. You said I had a romantic obsession with entropy. Now look at us, trying to outrun the universe's ultimate heat death. The Endeavour lifted off, its exhaust igniting ash clouds into temporary fireballs. As the second ship, Voyager, began its countdown, Sarah pointed to the horizon. A line of refugees, wrapped in radiation suits, stumbled toward the volcano, hundreds of thousands who hadn't made the Ark's strict genetic cutoff. We're leaving them behind, she said, her voice cracking. Ethan nodded, staring at the survival probability progress bar, now a faint red line on a failing screen. But we're taking their stories, their music, their hope. The chapter closed with the last starship vanishing into a sky, where the Milky Way was stretched into a luminous arc, its stars torn from their ancient patterns by the black hole's gravity. On the surface, the first survivors of Yellowstone's eruption emerged from bunkers, only to face a world where the sun had become a misshapen monster. The air smelled of sulfur and ozone, and the future was either a 4.2 light-year journey or slow, radioactive death. The survival probability progress bar, now a single pixel flickering in the darkness, seemed to whisper the oldest question of all. Was humanity's brief, brilliant existence worth the cosmic cost? Or were we always just a footnote in the universe's endless story? Chapter 7. The Solar Disruption. 20 months after the gravitational wave first announced the rogue black hole's presence, the interloper closed to 10 astronomical units, closer than Saturn's orbit and close enough for its gravity to turn the sun into a celestial ragdoll. The star, now stretched into an elongated ellipsoid, bulged 300,000 kilometers toward the black hole, its photosphere seething with superheated plasma torn from the convective zone. Heliographers at the last functioning observatory in the Atacama Desert captured the surreal sight, a solar tail of ionized gas streaming toward a black hole, a 10-million kilometer long ribbon of fire marking the star's gravitational surrender. Ethan, strapped into a crash couch aboard the Endeavour, stared at the live feed from the Solar Pro Plus, now the closest human-made object to the sun at $0 Australian dollars and 20 cents. The corona is expanding into black hole's gravity well, he said, voice trembling with awe and dread. We're witnessing a star being slowly eaten alive. 1 million tons of plasma per second stripped from the photosphere. The survival probability progress bar, now a dim red line on the starship's console, hovered at 30%, a number that matched the crew's odds of escaping the gravitational maelstrom. On Earth, the final act of geological fury unfolded. The planet's crust, strained beyond breaking point, fractured into a mosaic of tectonic plates, sliding chaotically. The mid-Atlantic ridge, torn open by gravitational shear, spewed 100,000 cubic kilometers of basaltic lava, creating a new oceanic crust that glowed red-hot for thousands of kilometers. In the Pacific, the ring of fire erupted in a synchronized fury. 37 active volcanoes, including Mauna Loa and Krakatoa, unleashed pyroclastic flows that incinerated coastal cities, while Marianas Trench sank an additional 2 kilometers, displacing enough seawater to raise global sea levels by 1.5 meters in 48 hours. Sarah, still on the surface in a radiation-hardened rover, navigated the ruins of Washington, D.C. The National Mall was a canyon of collapsed monuments, the Washington Monument leaning at a 45-degree angle like a broken tooth. Her mission: retrieve the Lunar Library's final data cache from the Smithsonian's underground archives. The black hole's gravity has increased Earth's axial tilt to 32 degrees, she reported to the Endeavour crew, avoiding a fissure-spewing sulfurous gas. Winter solstice in the northern hemisphere now receives 40% less sunlight. Agriculture is a memory. The interplanetary chaos reached a crescendo as Venus and Earth experienced a near miss of catastrophic proportions. The sister planets, their orbits warped into intersecting ellipses, came within 22 million kilometers, close enough for Venus' dense atmosphere to brush Earth's magnetosphere. The resulting gravitational slingshot accelerated Earth's rotation by 0.001 seconds per day, while Venus lost 5% of its atmosphere space, its sulfuric acid clouds raining down on Earth's upper atmosphere as a toxic haze. In space, the Starship fleet faced their own nightmare. The black hole space-time curvature had created a gravitational lens effect so severe that stars appeared as multiple images, their positions shifting by minutes of arc every hour. Navigation systems, relying on ancient astrometry, struggled to plot a course beyond the sun's gravity well. "We're caught in the gravitational crossfire," shouted Chief Engineer Raj Patel, as the Voyager reported a 0.3-degree trajectory deviation. The sun's being pulled toward the black hole, and we're collateral. On the ground, the last underground cities face a new threat. The Earth's core, destabilized by gravitational forces, began to slow its rotation. Geophysicists detected a 10% decrease in the inner core's angular velocity, disrupting the geodynamo and causing the magnetic field to collapse into a patchwork of weak flux regions. Radiation belts, once contained by the magnetosphere, now rained high-energy particles on the surface, turning the night sky into a permanent aurora of deadly gamma rays. Ethan and Sarah's paths converged at the Lunar Library's launch site in Iceland. The Endeavour had returned for the final payload. 500 cryogenically preserved embryos and the last copies of human art and literature. "This isn't just about survival," Sarah said, securing the data crystals into the ship's vault. "It's about ensuring that something of us endures, even if we don't." Their reunion was cut short by a seismic alert. The Icelandic volcanic system, overwhelmed by magma upwellings, was about to erupt. The ground beneath the Starship trembled as a 5-kilometer-wide caldera formed just 10 kilometers away, its rim glowing with molten rock. "We have 12 minutes before the lava flow reaches us," Ethan shouted, strapping Sarah into the co-pilot seat. "Hold on. This is going to be a rough ride." As the Endeavour lifted off, they witnessed the final destruction of Earth's surface. The North Atlantic Ocean, boiling from geothermal heat, erupted into steam explosions that tore apart coastal countries. The Amazon basin, now a desert of ash and lava, glowed under the misshapen sun's light. The black hole, now a gravitational colossus visible as a dark patch in the sky, began to pull the sun into a slow, fatal spiral, their combined gravity creating a space-time vortex that would eventually consume the inner solar system. In the silence of Starship's bridge, Ethan and Sarah watched as Earth shrank to a blue-green speck, its atmosphere already beginning to bleed into space. The survival probability progress bar, now a faint pixel, seemed to mirror their own odds. 30% chance of navigating the black hole's gravity well, 70% chance of becoming just another footnote in cosmic history. Remember when we thought understanding the universe was enough? Sarah asked, staring at the live feet of the sun being stretched into a stellar filament. Ethan nodded, placing a hand on her shoulder. Maybe it was never about understanding. Maybe it was about having the courage to look, even when what we saw terrified us. The chapter closed with the Starship fleet entering the gravitational lens zone, their sensors flooded with distorted images of a universe torn asunder by the rogue black hole's gravity. Behind them, the solar system was a dying symphony, planets careening off course, the sun a fading torch, and Earth a wounded blue planet gasping its last breaths. The survival probability progress bar, now a question mark in the cosmic void, reminded them that humanity's future was no longer written in equations, but in the fragile hope of a species that refused to go quietly into the dark. Chapter 8. The Gravitational Embrace. 22 months after the first gravitational wave rippled through LIGO's detectors, the rogue black hole hung at 5 astronomical units, closer to the sun than Jupiter's average orbital distance, and deep within the stellar Roche limit. The sun, once a perfect sphere, now stretched into a grotesque ellipse, its equator bulging 600,000 kilometers toward the interloper. Heliovisual sensors aboard the Endeavour captured the surreal spectacle. Tendrils of plasma, each wider than the distance between Earth and the Moon, peeled off the photosphere, spiraling into a glowing accretion disk around the black hole. The disk, a 10-million kilometer, wide ring of superheated hydrogen, emitted an ethereal ultraviolet glow that turned the inner solar system into a macabre theater of light and shadow. "We're witnessing the sun's final act," Ethan muttered, his voice trembling as he analyzed data from the Solar and Heliospheric Observatory. Mass loss rate has spiked to 1.2 times 10 superscript 1 superscript 2 kilograms per second, enough to vaporize a mountain of iron every 90 seconds. The convective zone is collapsing like a punctured balloon, and the core's fusion reactions are destabilizing. The survival probability progress bar on the bridge console, now a faint red thread, dipped to 20%, a numerical epitaph for a star system in its death throes. On Earth, the atmosphere was a dying organism. The black hole's gravitational gradient, now 0.05% of Earth's surface gravity at this distance, acted like a cosmic vacuum, pulling the thermosphere into space. Satellite imagery from the last functional CubeSat showed a blue hemorrhage, trailing the planet. 10,000 kilometers of nitrogen and oxygen molecules streaming into void, reducing surface oxygen levels by 0.4% per hour. In the Gobi Desert's last habitable bunker, Dr. Anika Roy recorded a historic milestone. At 1400 hours Universal Time Coordinated, the oxygen sensor dipped below 15%, the threshold for human survival without supplemental air. "It's a race against asphyxiation," she reported, her voice steady only through years of training to stay calm. "By midnight, even the thickest pressure suits will fail." The oceans, too, rebelled against the laws of nature. The combined gravitational pull of the black hole and the Moon, now a distant erratic companion, created a global supertide that raised sea levels by 8 meters in 12 hours. In Mumbai, the Arabian Sea surged over the whirly sea-faced promenade, swallowing high-rise apartments like child's play. Helicopter footage showed thousands clinging to the rooftops of the World Trade Center Mumbai, their screams drowned by the roar of collapsing infrastructure. The city's iconic Marine Drive became a graveyard of submerged cars, their taillights flickering like dying fireflies beneath the murky waves. In the Pacific, the Marianas Trench, strained by gravitational shear, widened by 50 meters, displacing enough seawater to form a mega tsunami that slammed into Japan's eastern coast. The 40-meter-high wave, laced with radioactive debris from Fukushima's long-abandoned reactors, reduced Sendai to a radioactive wasteland in minutes. "The ocean itself is a weapon now," Sarah murmured, watching a live feed from a drone hovering above the disaster zone. "Every cubic meter carries enough cesium, 137 to kill a human in 48 hours. In space, the Starship fleet navigated a gravitational minefield. The black hole space-time curvature, measuring 0.015 radians per AU, created a lensing effect so severe that stars appeared as fractured prisms, their positions shifting by arc minutes every minute. The Voyager, trailing the Endeavour by 500 kilometers, narrowly avoided collision with a chunk of Mercury's molten core, now a 200-meter-wide asteroid traveling at 30 kilometers per second. "It's like flying through a storm of shrapnel," shouted Chief Engineer Raj Patel, as the ship's hull rang with the impact of micrometeoroids. "Our ablative shielding is down to 30%, one more direct hit, and we're venting atmosphere." Sarah, meanwhile, oversaw the activation of the stellar seed protocol in the Endeavour's biolab. Using CRISPR-edited tardigrade genomes as hosts, her team encapsulated 10,000 human embryos in desiccation-resistant capsules. "These aren't just genetic codes," she told a weary crew member, holding up a translucent pod no larger than a thumbnail. "They're a promise, a guarantee that even if we burn up in this gravitational hell, something of us will endure, resilient, patient, waiting for a new star to rise." Back on Earth, the final act of geological fury unfolded. The Earth's core, now rotating 25% slower than its natural rate, caused the planet to vibrate at a subsonic frequency, audible as a deep, mournful hum through the bedrock. In Yellowstone, the caldera, now a 50-kilometer-wide chasm, belched ash into the stratosphere for the final time, its pyroclastic flows incinerating the last remaining forests in the Rocky Mountains. Polar bears in Svalbard, their ice flows reduced to molten slush, wandered aimlessly across volcanic ash fields, their fur caked in sulfur, living symbols of a world unmade. Ethan's focus remained on the black hole's event horizon, now a visible absence of light against the star field. Using the ship's onboard interferometer, he made a groundbreaking, if tragic, discovery. The black hole's mass had increased by 4.7% since its first detection, fueled by the sun's stolen matter. "It's not a passing visitor," he said, pulling Sarah to the main view screen. "It's a predator. The sun's gravity well is collapsing, and we're caught in the undertow." The final crisis came without warning. At 21:43 Universal Time Coordinated, the sun's north pole tore open, unleashing a coronal mass ejection, CME, the size of Neptune. The plasma cloud, traveling at 0.15 C, hit the Endeavour's forward shield with a force of 1,000 nuclear bombs. The ship lurched violently, throwing crew members into the bulkheads as emergency lights strobe red. "Shield integrity, 8%, shouted Lieutenant Marquez, fighting to stabilize the controls. Magnetic confinement failing. Heat signature at 1,800 degrees Celsius. As the engines roared to life with final burn, Ethan and Sarah clung to each other, staring at the view screen as their home star met its end. The sun, now a fragmented mess of glowing gas and dark voids, pulsed irregularly, its light warped into a kaleidoscope by the black hole's gravity. Earth, visible as a tiny blue-green on the edge of the accretion disk, disappeared behind a veil of solar debris, its atmosphere already a thin wisp, its oceans boiling away into space. Remember our first conference in Geneva? Sarah shouted over the roar of failing systems, a tear mixing with the sweat on her face. You said humanity's greatest achievement was curiosity, not survival. Ethan smiled, pressing a kiss to her ash-streaked forehead. Curiosity brought us here, but survival? That's the ultimate act of defiance. He nodded to the cryo bay, where the tardigrade capsules glowed like tiny constellations. We're not just running. We're planting a seed, one that might grow in a galaxy where this horror is just a footnote in the cosmic record. The Endeavour cleared the gravitational lens zone at 23:59 Universal Time Coordinated, its engine sputtering on fumes. Behind them, the solar system was a graveyard. Mercury vaporized, Venus a molten cinder, Mars a cracked desert, and Earth a lifeless rock in the grip of a dying star. The black hole, now bloated with solar matter, began its slow journey back to the galaxy's core, leaving behind a trail of stellar debris and the faint, fading light of a once vibrant star. The survival probability progress bar, now a blank screen on the bridge, told the final truth. Humanity's odds were no longer quantifiable. They were adrift in the cosmos, a tiny ark carrying the last whispers of a blue planet story. But as Ethan and Sarah watched the accretion disk glow fade into the dark, they held on to the only certainty left. That for a brief, brilliant moment, a species called Homo sapiens had dared to look up, to understand, and to fight, even when the universe itself seemed determined to silence them. The chapter closed with the Endeavour setting course for Proxima Centauri, its crew staring at the stars ahead, stars unbent by gravitational monsters, untainted by dying suns. Behind them, the solar system's death throes continued, a cosmic symphony of destruction that would echo for eons. But in the ship's cryo bay, the tardigrade capsules waited, patient, resilient, holding within them the most tenacious force in the universe, the will to endure against all odds for as long as light itself burned. Chapter 9. The Final Orbit. 23 months after the gravitational wave first disrupted LIGO's detectors, the rogue black hole loomed at 1 astronomical unit, equidistant from the sun as Earth's orbit and close enough for its gravity to rewrite the laws of the solar system. The sun, now a fragmented stellar corpse, had lost 30% of its mass to the black hole's accretion disk. Its photosphere, once a smooth orange frontier, was a chaotic mess of boiling plasma rivers, each wider than Earth, streaming toward the black hole like cosmic tributaries feeding a gravitational ocean. Ethan stared at a live feed from the Endeavour's external cameras, his face illuminated by the surreal glow of the dying star. We've entered the sun's Roche limit for planetary disruption, he said, voice hollow with scientific detachment. Any object within 1.5 million kilometers will be torn apart by tidal forces, including Earth, in approximately 12 hours. The survival probability progress bar, now a single red pixel on the bridge console, flickered at 10%, a statistical whisper of what remained. In the inner solar system, chaos reigned supreme. Mercury, already vaporized, had become a cloud of iron vapor orbiting the black hole. Venus, its surface a molten sea of lead, was being pulled into a spiral toward the sun, its atmosphere a tail of sulfuric acid trailing behind. Mars, caught in the gravitational crossfire between the sun and the black hole, had its orbit destabilized. Astronomers aboard the Voyager witnessed a 200-kilometer-wide asteroid from the main belt collide with the red planet's southern hemisphere, creating a crater the size of Texas and ejecting debris that would rain down on Earth's remains. But the most surreal sight was Jupiter. The gas giant, now 10% closer to the sun than its natural orbit, had begun to flatten into an oblate spheroid, its cloud bands warped into concentric rings by the black hole's gravity. The great red spot, once a storm larger than Earth, dissipated into a diffuse red haze as Jupiter's gravitational field struggled to contain its own mass. Jupiter's core is heating up, Sarah reported, analyzing data from the Juno probe, now a dead hulk in a decaying orbit. Another 48 hours, and we'll see methane eruptions on a planetary scale. Nature's final fireworks. On Earth, the final hours unfolded with geological finality. The planet's crust, strained beyond endurance, fractured into a mosaic of tectonic plates the size of continents, each sliding chaotically over the molten mantle. The mid-Atlantic ridge, now a 10,000-kilometer-long fissure, spewed basaltic lava into the Atlantic Ocean, creating a glowing sea of fire that vaporized seawater on contact, sending plumes of steam 100 kilometers into collapsing atmosphere. In the Pacific, the Ring of Fire had become a continuous chain of eruptions, with Mauna Loa and Krakatoa erupting in unison, their pyroclastic flows merging into a single continent-spanning wave of ash and fire. The atmosphere, now a thin shell of nitrogen and oxygen, continued to bleed into space at a rate of 1,000 tons per second. Surface oxygen levels had dropped to 8%, below the threshold for even anaerobic organisms. In the Gobi Desert Bunker, Dr. Anika Roy recorded the last human heartbeat on Earth at 3:47 Universal Time Coordinated, an elderly scientist named Dr. Li Wei, who died peacefully in his sleep, his life support system failing as the bunker's oxygen reserves ran dry. In space, the Starship fleet faced their own existential crisis. The Endeavour and Voyager, the only two ships to clear the gravitational lens zone, were now struggling with dwindling hydrazine reserves. "We have enough fuel for one final burn," Raj Patel announced, his voice tight with stress. "Either we commit to a slingshot around Jupiter to gain velocity, or we accept that Proxima Centauri is beyond our reach." Ethan and Sarah stood at the Endeavour's observation deck, watching Earth's final moments. The planet, now a cracked and burning sphere, was visible as a tiny, flickering in the view screen, its surface illuminated by the red glow of the dying sun and the blue-white flash of volcanic eruptions. "Do you remember the first time we saw Earth from space?" Sarah asked, her voice trembling. It was so fragile, so perfect, like a blue marble floating in the dark. Ethan nodded, recalling the image from the Apollo 17 mission, the last time humans had seen their planet in its entirety. "We thought we had forever," he said. "Turns out, we were just guests in a universe that doesn't care about guests." He pointed to the cryo bay, where the tardigrade capsules hummed softly in their refrigeration units. But maybe that's the point, to be guests who left a mark, however brief. The decision was made. The fleet would attempt the Jupiter slingshot, despite the 70% chance of being pulled into the gas giant's gravity well. As the Endeavour turned toward Jupiter, its engines firing for final trajectory correction, Ethan and Sarah witnessed the most humbling sight of all. The black hole, now a gravitational behemoth equal in mass to the sun itself, began to merge with the dying star. The accretion disk, now a searing ring of plasma, brightened to 1,000,000 times the sun's normal luminosity, creating a new artificial star in the solar system, one that would burn for millennia, a tombstone for the system it had destroyed. On Earth, the final geological event unfolded. The core, now a molten sphere spinning freely within a fractured crust, caused the planet to vibrate at a frequency that shattered the remaining tectonic plates. The Americas, separated from Eurasia by a 500-kilometer-wide rift, began to sink into the mantle, their continents crumbling into the fiery abyss. The last image transmitted from Earth's surface, captured by a lone weather satellite, showed the African continent floating like an island on a sea of lava, its highest peaks, Kilimanjaro, glowing red as they melted into the crust. But even in the face of annihilation, science prevailed. The Endeavour's interferometer captured the precise moment of solar disruption, transmitting the data to the Lunar Library's archives. 30 terabytes of information about stellar death, gravitational physics, and the final moments of a species that had dared to understand. "We're not just survivors," Sarah said, securing the last data packet. "We're the universe's witnesses. And witnesses have a duty to remember." The chapter closed with the starships approaching Jupiter, their engines firing against the gas giant's gravity well. Behind them, the solar system was a graveyard of shattered planets and a dying binary system of sun and black hole. The survival probability progress bar, now extinct, was replaced by a new reality. Humanity's fate was no longer a number, but a journey, one where the destination was unknown. But the legacy was written in the stars they had once called home. As Ethan and Sarah prepared for the slingshot maneuver, they looked back at the glowing accretion disk, a paradox of destruction and beauty. It was a fitting end to a cosmic drama. A species that had risen from stardust, learned to read the universe's code, and then watched as that same universe erased its masterpiece. But in the Endeavor's cryo bay, the tardigrade capsules waited, patient, resilient, carrying the most enduring legacy of all, the human story, written not in equations, but in the courage to look, to understand, and to keep going, even when the universe itself said goodbye. Chapter 10. The Solar Funeral. 24 months after the gravitational wave first disturbed LIGO's detectors, the rogue black hole reached its perihelion at 0.5 astronomical units, closer to the Sun than Mercury's closest approach, and deep within the star's Roche limit for complete disruption. The Sun, now a fractured inferno, had lost 40% of its mass, its photosphere torn into a swirling maelstrom of plasma tornadoes, each wider than the distance between Earth and Venus. Heliovisual sensors aboard the Endeavor captured the apocalyptic sight, a 20-million-kilometer long jet of superheated hydrogen, accelerated to 10% the speed of light, spewed from the Sun's polar regions, ionizing the interplanetary medium into a glowing shroud. Ethan gripped the console as the ship shuddered from the radiation pressure, his eyes fixed on the spectrogram, showing the Sun's spectral lines collapsing into a red-shifted blur. "This is it," he said, voice steady despite the adrenaline surging through his veins. The Sun's core is exposed. In 90 minutes, the gravitational gradient will exceed the star's internal pressure. We're about to witness a stellar disintegration. The survival probability progress bar, now a faint smudge on the bridge display, flicker at 5%, a numerical epitaph for the solar system. On Earth, the final geological collapse unfolded with merciless efficiency. The planet, now caught in the black hole's tidal grip, was stretched into an oblate spheroid, its crust fracturing along every fault line. The mid-Atlantic ridge, already a gaping wound, widened to 1,000 kilometers, exposing the glowing mantle beneath. In a final violent convulsion, the Earth's core broke free from the crust, a 3,500-kilometer wide sphere of molten iron and nickel erupting to the Pacific Ocean basin, vaporizing seawater in a 10,000-kilometer high plume of steam and superheated plasma. Sarah, monitoring Earth's vital signs from the Endeavour science deck, saw the last gasp of the planet's magnetic field, a flickering aurora of X-rays and gamma rays, the final discharge of a dying geodynamo. "Atmosphere's gone," she reported, voice cracking as she watched the last traces of oxygen and nitrogen bleed into space. Surface temperature just hit 1,200 degrees Celsius. Even the tardigrade capsules on the moon would be incinerated. In space, the Starship fleet faced a graveyard of planets. Jupiter, its cloud bands torn asunder, had lost 25% of its mass to the black hole's gravity, its core visible as a glowing through the disintegrating gas layers. Saturn's rings, once a celestial masterpiece, were now a chaotic debris field, their icy particles accelerating into black hole's accretion disk, creating a million-mile-long chain of explosions as they crossed the event horizon. The Endeavour and Voyager, the only ships to survive the Jupiter slingshot, now faced a final choice: burn the last hydrazine to escape the solar system, or turn back to document the Sun's death. "We have enough fuel for one trajectory correction," Raj Patel said, his hands hovering over the thruster controls. Proxima Centauri is 4.1 light-years away. Without a gravity assist, we'll never make it. But if we stay, we become the last witnesses. Ethan finished, locking eyes with Sarah. She nodded, tears streaming down her face as she activated the high-resolution interferometers. The lunar library needs this data. Future civilizations, if they exist, deserve to know how it ended. As the Endeavour turned toward the dying sun, Ethan and Sarah watched Earth's final moments through the observation deck. The planet, now a shattered husk, was being pulled apart by tidal forces, its mantle material forming a dusty ring around the black hole. The last visible feature was the African continent, now a floating island of scorched rock, its highest peaks, Kilimanjaro, glowing white-hot as they melted into the cosmic void. The sun's disintegration began at 6:12 Universal Time Coordinated. The core, no longer able to withstand gravitational pull, collapsed into a dense knot of plasma, triggering a shock wave that tore the remaining photosphere into shreds. The resulting explosion, though silent in the vacuum, was visible as a rippling wave of incandescent gas, consuming Mercury and Venus in an instant. Mars, already a dead planet, was catapulted out of the solar system by the blast, its rusted surface forever marked with the scars of humanity's last rovers. In the Endeavour's cryo bay, the tardigrade capsules hummed softly, their tiny inhabitants in suspended animation. Sarah traced a glass of a capsule, wondering if any of them would ever wake in a new solar system. "We were never meant to outlive our star," she said, leaning into Ethan's shoulder. "But we did something no other species has done. We understood our own extinction in real time." Ethan smiled sadly, watching the black hole's accretion disk brighten to 1 billion times the sun's original luminosity. Maybe that's a true miracle, consciousness itself. To look up, to ask why, even when the answer is a black hole in the sky. The final transmission from the Endeavour lasted 17 seconds, a burst of data containing the sun's spectral signature at the moment of disintegration. Then, as the black hole's gravity became irresistible, the ship's engines failed, and the Endeavour began its slow, inevitable descent into the accretion disk. In the last moments of coherent thought, Ethan and Sarah stared at the view screen, where the solar system was reduced to a glowing disk of gas and dust, with Earth's remains a tiny blue speck in the chaos. The survival probability progress bar, now a blank screen, symbolized the end of the species that had dared to measure the universe, only to find itself insignificant yet infinitely curious. The chapter closed with the Endeavour's hull heating to 20,000 degrees Celsius, its crew lost in a blaze of plasma. Their final act of silent salute to a star that had birthed them, a black hole that had destroyed them, and a universe that continued spinning, indifferent yet magnificent. The last message from humanity, etched into the lunar library's quartz crystals, was a simple equation, E equals MC superscript 2, a testament that once, for a brief moment, a species had understood the language of the cosmos, even as they became part of its eternal silence. Chapter 11. The Cosmic Epitaph. The lunar library's quartz crystals hummed faintly in the vacuum, their surface etched with 22,000 terabytes of data. Every major scientific equation, every recorded human language, every star chart of the solar system that once was. Sealed in a radiation-shielded vault beneath the mare imbrium, the library had survived the initial gamma-ray burst intact, its synthetic quartz matrix, 12 centimeters thick, designed to resist cosmic radiation for 1.2 million years per 2023 Cambridge durability tests. 52 hours after the sun's disintegration, the Endeavour's hull fractured under the accretion disk's 20,000 degrees Celsius plasma, scattering debris across the event horizon. The 12 tardigrade capsules, jettisoned at 18.7 kilometers per second, precisely the local escape velocity, began their aimless drift through the debris field. Each capsule held 1,500 dehydrated Hypsibius dujardini, their DNA repair mechanisms capable of withstanding 5,000 grays, surpassing human tolerance by 1,250 times, but well within the known limits of extremophiles. On the remains of Earth, now a 12,000-kilometer wide debris ring, the fused crust of the African continent cooled into a dark, airless asteroid. The former peak of Kilimanjaro, reduced to a 50 kilometers rock nucleus, orbited the black hole alongside fragments of Venus and Mercury, their surfaces scarred by post-apocalyptic vitrification. The only organized signal in the graveyard came from the Lunar Library's beacon, a 17-second pulse encoding pi and E equals mc squared, broadcast every 90 minutes on a 406 megahertz emergency band. Inside the library, the last surviving camera drone captured the black hole's accretion disk, a 600,000 km wide inferno-emitting X-rays 10 to the power of 8 times brighter than the original sun. The feed lasted 37 minutes before the lens melted, but the event was already logged in the quartz storage. A final scientific observation, time-stamped 941 Universal Time Coordinated, April 12, 2027. In the Endeavour's cryo bay, the last surviving monitor flickered to life briefly, showing the tardigrade capsule's telemetry, all systems dormant, internal temperature steady at minus 270 degrees Celsius. The signal cut out at the exact moment the ship's hull integrity failed, leaving the tiny passengers to drift in eternal freeze, their dehydrated bodies the only biological matter left from a planet that had teemed with life. The Lunar Library's beacon continued its cycle, oblivious to the absence of observers. Its message would outlast the moon itself, a silent testament to a species that had measured the cosmos, named its stars, and dared record its existence even as it vanished. There was no grand narrative here, no cosmic redemption, only the cold, beautiful math of a universe that had birthed consciousness, if only for a heartbeat. And so the black hole wandered on, consuming the last vestiges of a solar system now reduced to plasma and dust. The tardigrade capsules, too small to ever be found, carried no hope of revival, just the quiet persistence of matter, obeying the laws of physics that humans had spent millennia deciphering. In the end, science had no need for epilogues. The facts endured, indifferent to the fleeting drama of life that had briefly marveled at them.